Hello, and welcome to Developing Mathematical Literacy, the second of 3 webcasts in the Meeting the Challenges of the Ohio Core series. This series focuses on the challenges facing Ohio's mathematics programs and teachers as they prepare students to meet increased graduation requirements for mathematics. My name is Ann Meixel, and I am a consultant for mathematics projects at the Ohio Resource Center for Mathematics, Science, and Reading. This webcast models professional discussion about mathematics teaching and learning among teachers, curriculum specialists, and other leaders in mathematics education. Support materials related to today's topic, including an article, viewer's guide, mini collection, and other tools, can be accessed before, during, and after you view this webcast. Results from national and international assessments and mathematics reform efforts at the state and national levels have turned attention to the question, what mathematics knowledge and skills are needed for success in mathematics courses and in other content areas at both the K-12 and the post-secondary education levels, in the workplace, and in daily life. Today we will address this important question by looking at mathematical literacy and quantitative literacy, including implications for middle grade instruction in mathematics and across content areas. Our panelists today are Bob Reynolds, the coordinator of secondary programs for the Forest Hills School District. Bob is a former mathematics consultant for the Hamilton County Educational Service Center and a former 712 mathematics teacher. Judy Spicer, a mathematics content specialist at the Ohio Resource Center. Judy has taught mathematics at the high school and community college levels. Currently, she develops mathematics content for the Ohio Resource website and works with Ohio teachers to implement standards-based instruction. And finally, Yelena Paleva, a mathematics consultant for the Ohio Department of Education. Yelena is responsible for the development of grades 7 and 8 Ohio Achievement Test items and works with Ohio schools to implement mathematics initiatives. She also worked as a middle and high school mathematics teacher in Russia. Welcome, Bob, Judy, and Yelena.
Happy to be here.
Thank you, Ann.
Soon, all Ohio students will be required to earn 4 units of credit in high school mathematics, including Algebra 2 or its equivalent. These increased requirements are intended to prepare all students to meet the demands of the workplace and college. However, the mathematical understandings needed for success in school and beyond are developed well before entering high school. A number of terms are used to describe the level of mathematics understandings and skills that all students need to develop during their schooling: mathematical power, mathematical literacy, quantitative literacy, numeracy, mathematics proficiency, to name a few. Yelena, what are the key elements of mathematical literacy?
Well, before we go deeper into the discussion about mathematical literacy and quantitative literacy, I would like to share with you a definition of mathematical literacy. Mathematical literacy is an individual's ability to use mathematics as a fully functioning member of the society. The term literacy refers to the human's ability to use a language. A literate person knows the resources of the language and knows how successfully to use it in different situations, either life situations or professional situations. In the same way, a mathematically literate person knows the resources of mathematics and can use them appropriately where it is necessary. To utilize a power of mathematics, an individual should gain a knowledge of mathematics facts, understand mathematical concepts, develop mathematical skills, knows how to use mathematical procedures, and understands a structure of mathematical ideas within mathematical domain.
The Ohio Mathematics and Science Coalition, Ohio Department of Education, and Ohio Resource Center are collaborating in a series of conferences to develop awareness and action around quantitative literacy. At the most recent conference, the keynote speaker, Deborah Hughes Hallett, described quantitative literacy as the ability to identify, understand, and use quantitative arguments in everyday contexts. She described it as a habit of mind rather than a list of topics or skills. Judy, how is quantitative literacy different from mathematical literacy?
Well, in the past, literacy and mathematics were seen as unconnected. Today, mathematics literacy often refers to understanding and using the mathematics found in schools with its symbols, algorithms, formal reasoning, and sometimes difficult to understand or appreciate real-world examples. Quantitative literacy, on the other hand, addresses the quantitative aspects of life, is more broadly accessible, and grows out of experience. Quantitative literacy is often called numeracy and is part of the 21st century skills students need and reflects the process skills found in the Ohio Mathematics Content Standards. In summary, we can say that mathematical literacy requires wide knowledge of mathematics and the ability to abstract away from context. Quantitative literacy requires fluency in elementary mathematics and statistics and the ability to think in context.
Bob, how does quantitative literacy fit within the broader context of literacy?
I think we may need to define the term literacy a little bit more clearly in light of our quantitative literacy definitions that have been shared already. Typically, we have in the past defined a numerate person as maybe somebody who is good at computation, maybe who is good with number facts, and I think we need to broaden that a little bit more to make that definition inclusive of some of these other components that Judy and Elena have shared. Literacy could be defined with two aspects, verbal literacy and quantitative literacy, and without the ability to read and understand, no one can be mathematically literate. Along with that, without the ability to understand basic mathematical ideas, no one can comprehend modern writing. So we would not define somebody as literate who was good at grammar and spelling rules, just as if we probably do not want to define somebody who is quantitatively literate as someone who's just good at computational skills.
One of the descriptions of quantitative literacy shared by Bernie Madison from the University of Arkansas and a leader in quantitative literacy is quantitative literacy is a cultural field where language and quantitative constructs merge and are no longer one or the other. Bernie describes quantitative literacy as the ability to understand and use numbers and data in everyday life. We and students see data and graphs everywhere, not just in school. Let's look at a released item from the National Assessment of Educational Progress. This item from 1992 is kind of a hybrid between a pictograph and a bar graph. Students typically do well on items related to reading graphs on the Ohio Achievement Test, but only 8% of the 8th grade students were able to describe how this graph is misleading. Elena, what does this item tell us about students developing mathematical and quantitative literacy?
Well, since Anne, you mentioned that only 8% of the students got this item answered correctly, we can conclude that students had hard time using either their quantitative literacy or mathematical literacy. But should students use mathematical literacy to solve this problem? Not necessarily. They can use their quantitative literacy skills to solve this problem. First of all, in order to explain why this pictograph is misleading, they have to observe the graph. Notice that two trash cans are of the different size, and the smaller trash cans is about half of the height of the larger trash can and half radius of the larger trash can. They also need to observe that above both trash cans, they're given the volumes of those trash cans. So students can use the estimating techniques and try to fit the smaller trash can into the larger trash can. They can see that a smaller trash can go more than twice into the larger trash can. On the other hand, students could use their mathematical literacy to solve those problems, associate those trash cans with cylinders and use the formulas for the volume of the cylinders to solve this problem. And can see that the volume of the larger trash can will be more than twice larger than the volume of a smaller trash can. So what might be misleading then in this item? A picture, given then the labels are correct.
Bob, what does this mean for middle school instruction?
Well, this problem assumes that there's been some work done with students in terms of volume and understanding the relationship between volume and what happens when you double the height of a three-dimensional object, or for that matter, a two-dimensional object. It is not strictly in the realm of the data analysis graphing standard or strand. It does embed a lot of geometric and measurement concepts. So there are a lot of other connections, I think, that would have had to have happened and occurred prior to this item being given on a formal assessment.
Here's another example that comes directly from the media. This is in response to an article that appeared about the proportion of the cost of gasoline taxes contribute in Britain. And we see that the article indicated that 80% of the cost of the gas was tax. Is it possible, Judy, for someone to be mathematically literate and not quantitatively literate, or quantitatively literate and not mathematically literate?
Yes. Either literacy type is possible alone. In a perfect world, everyone would be both mathematically literate and quantitatively literate. In reality, mathematics literacy requires a wider knowledge of mathematics and the ability to abstract. Meanwhile, quantitative literacy requires elementary mathematics and statistics knowledge, along with the flexibility to problem solve and apply mathematics in everyday context. In this example, we have a very literate caller who understands the mathematics of proportion and can apply it correctly to the tax rate. Clearly, this caller finds satisfaction in using mathematics to understand and explain the world. When this tax question was given to students in the U.S., they knew that 8 is 80% of 10, but understanding why the caller said the tax rate was 400% was not clear to most of them.
Bob, can you share an example from the Ohio Achievement Test?
Sure. This is from the 2005 Grade 7 OAT, and this is a problem involving proportional reasoning, dealing with a person standing who is 5 feet tall who casts an 8-foot shadow compared to a tree which casts a 32-foot shadow, and the task was to find the height of the tree. On this particular problem, you could simply see that for many students they could have used just some quantitative reasoning skills, some quantitative literacy components to look at the fact that the length of the shadow is about 4 times as long for the tree as it is for the person. Yet many students did not see that number sense skill for them, and they got caught up in some of the procedural components of setting up a proportion and solving the proportion, getting into the algorithm and the formula. They really did not see what was very obvious from a sense of just looking at the problem from a number sense point of view. Over half of the students, or actually a little bit under half of the students, chose answer C, which was found simply by doing a subtraction, which was an incorrect response. About 1/4 of the students chose answer D, which was found incorrectly by not realizing that the height of the person was a little over half of the height of the shadow. The correct answer of A was the answer that could have simply been found by using some simple reasoning skills.
It sounds like key elements of both mathematical literacy and quantitative literacy are strongly linked to the mathematical processes. problem solving, reasoning, representation, communication, and making connections within mathematics as well as to other content areas and practical contexts. Let's look at an example from the 2006 Ohio graduation test for science. A snowboarder begins his run from rest on the top of a hill. He moves straight down the slope until he reaches the bottom of the hill and the ground levels off. The snowboarder continues to move horizontally across the level ground and eventually comes to a stop. This item is intended to look at one of Newton's laws. The students are asked to select from among 4 graphs the one that illustrates the snowboarder's speed as he moves down the hill. This looks kind of like a math problem. Bob, what do you think this shows us about mathematical literacy?
Well, it does show one misconception that often comes up when students are asked to compare the representation of a particular context as a graph as it compares in real life. The correct answer for this particular question was answer B, and answer B shows correctly the speed versus time relationship as the snowboarder moves from point 2 to point 3. However, many students chose answer C incorrectly, and what they are looking at is simply the path of the object, the snowboarder moving down the slope of the hill, and comparing that to the shape of the graph. And the misconception being that whenever there's an object moving through space, that the graph of that object is going to look like the graph shown in a representation such as this.
Judy, anything you would like to add?
Well, yes, Anne, thanks for asking. An important part of any type of literacy is understanding the vocabulary. This test item points to the often problematic and confusing situation in mathematics where students encounter a word with a common colloquial meaning and a more technical mathematical meaning. Consider here the word slope and its common meaning, which is important in this question. The student needs to think through the use of the word slope to answer the question correctly.
Let's look at some released items from the 2007 Grade 5 Social Studies Ohio Achievement Test. The first shows a map of Ohio with a scale, and students are asked to identify a city that is 100 miles away from Columbus. The second item is a pretty straightforward item asking students to construct a bar graph using data given in a table. Yelena, what implications do these items have for planning instruction? Do you think teachers and students recognize fully the connections between the benchmarks and expectations for social studies and mathematics?
No, I don't think so. I don't think that students or teachers saw a mathematics concepts behind those behind those 2 items. If we take a look again at the map item where students need to identify a city which is 100 miles away from Columbus. What they have to do here is to use their common sense of their quantitative literacy skills and eliminate those cities whose distances from Columbus are either greater or less than 100 miles or 2 scale factors. However, only 50% of the students got this item correct. If we look at the other item where students need to create a bar graph from the information given in the table, again we see that only 20% of the students got this item answered correctly, where the whole issue of constructing bar graphs were taught back in grade 3 of mathematics classes. What kind of information these 2 examples can provide to teachers? For mathematics teachers, it means that they have to spend more time on developing students' insight in recognizing mathematics ideas in the context. For all other teachers, it means that they should partake in interdisciplinary discussion.
Bob, what strategies do you use with teachers and principals to improve quantitative literacy across the content areas?
Well, there are several things that that we can do. One of the things that I think we should be doing more is finding those content connections that exist, not in a formal mathematical sense, but maybe just the ideas that show up in other content areas that exist in mathematics. Things like the proportional reasoning idea of how cells and volume occur in a lot of different science topics, how in novels and literature there are mathematical ideas out there that teachers could tie together and use as a way of promoting quantitative literacy. It will require that all teachers take ownership in this, and that sometimes can be a challenge, but I think we need to redefine again what is important in terms of mathematics and mathematical literacy, and think of literacy being a broader term than just reading and writing. We try to get across the point that all teachers are reading teachers. Maybe we should be saying all teachers are quantitative literacy teachers also.
Yelena, how is the Ohio Department of Education planning to incorporate quantitative literacy into the revised content standards for mathematics and other content areas?
Obviously, ODE recognizes an importance of implementing quantitative literacy into the new and revised content standards. However, the final decision has not been done yet. It is evident that quantitative literacy is supposed to exist not only in mathematics courses, grades from 9 to 12, and be responsibility only of mathematics teachers. Quantitative literacy should be infused in all content areas. Quantitative literacy is an ability of individual to see a quantitative relationships in different contexts. Quantitative literacy is not a curriculum and not a single course, so it should be taught in a different context. Today, throughout our discussion, we had an opportunity to see several opportunities for connection to quantitative literacy in science and social studies. ODE is looking for ways to make those opportunities more explicit. Also, ODE is trying to find a way to encourage teachers to find those ways, to use those ways, and to support teachers for implementing those opportunities.
Now I'd like to ask each of our panelists to share one more practice or tip that teachers can use to strengthen their students' mathematical literacy and quantitative literacy. Judy, would you like to go first?
Of course. I'd encourage people to go to the tools and resources associated with this webcast, because ORC has been working for a year now on helping teachers incorporate literacy skills, including the vocabulary that I mentioned earlier, into their mathematics process to enrich mathematics understanding.
Bob?
Yeah, I think there are many places where the mathematically inclined teacher, the algebra teacher, can demonstrate how important mathematics is, but I also think there are other places where we need to emphasize for those students who maybe have a dislike for mathematics, and we need to pay attention to what the National Research Council calls productive disposition for mathematics students, and how they feel about mathematics and how powerful or lack of power they feel about mathematics. And by high school, many students have lost a lot of that, and we don't need formulas and complicated ways of teaching mathematics to get across some really important mathematical ideas for those students.
Yelena?
And I think all kinds of teachers are supposed to be given more opportunities for interdisciplinary discussion.
Thank you, Judy, Bob, and Yelena, for sharing your expertise and participating in this webcast.
Welcome.
And thank you for having us here.
And thank you for your participation. Today we talked about mathematical literacy and quantitative literacy, their similarities and differences. We've also discussed the need to incorporate with our colleagues in other content areas in collaboration to develop quantitative literacy and not just math. I got that messed up. Let's start that again. Okay. Okay. I'm supposed to tell you to jump right in there as soon as I thank you. Okay?
Mm-hmm.
Thank you, Bob, Judy, and Yelena, for participating in this webcast and sharing your expertise with other mathematics educators.
Take 3.
Okay, let's try it again.
You're welcome.
Yeah.
That's easy. I've done the whole thing.
Oh, okay. All right. So not to wait for them to respond before I say thank you. Okay. I'm going to go through that sentence about thanking you for participating in the webcast and sharing your expertise with Ohio's mathematics educators. And then I'm going to say, look at you and say thank you, and you respond immediately, okay? Thank you, Judy, Bob, and Yelena, for participating in this webcast and sharing your expertise with Ohio's mathematics educators. Thank you.
You're welcome.
And thank you for having us here.
And thank you for your participation. Today we talked about mathematical literacy and quantitative literacy, their similarities and differences. We've also discussed the need to collaborate with our colleagues in other content areas, as quantitative literacy is not limited to just mathematics class, but rather is a natural component of all content areas. Perhaps the statement in NCTM's Principles and Standards for School Mathematics sums it up best. We owe our children no less than a high degree of quantitative literacy and mathematical knowledge that prepares them for citizenship, work, and further study. We've only scratched the surface of these topics. Additional information and supporting materials can be found on the Mathematics Meeting the Challenges of the Ohio Core link on ORC's Mathematics Educator page. If you would like to learn more about these topics, please contact ORC at web@ohioRC.org. ORC would be happy to work collaboratively with you to plan building or district-wide professional development programs. For the Ohio Resource Center, I'm Ann Meixel, wishing you success with all of your work in mathematics teaching and learning.